Hello, I'm Dr. Kristine Pankow. I'm the Associate Director of the University of Utah Seismograph Stations, and I'm here to talk to you about seismic monitoring at the Forge site. So why are we talking about seismic monitoring? Well, commonly when we talk about seismic monitoring, we're talking about earthquakes, but different types of activity can also generate seismic ground motions. And in Utah, we actually see seismic ground motions that we record on our seismometers from earthquakes, the gray dots in the map. They occur along the I-15 corridor and something we call the Intermountain Seismic Belt. We also get seismic ground motions and seismic events from industrial activities. So we see small seismic events induced by mining in the Wasatch Plateau and the Book Cliffs, shown by the hatched region in central Utah. There's water injection induced seismic events out in the Paradox Basin on the Colorado border. We have quarries and mines shown in orange and yellow circles on the map. And in addition to the industrial activities, we have military activities where there's things being exploded out at Dugway and at the Utah Test and Training Range. So all of these different activities produce ground motions, and actually in geothermal areas, we also, like in mining induced seismicity, you can also induce earthquakes, so you induce these seismic events. They don't tend to be large events, but they do happen, most notably Basel, Switzerland, and in Korea. So before we even put Forge in and talked about Forge, we looked at seismicity here to see what the potentials for induced events might be. And, you know, again, on the left, we have a map of earthquakes. So again, this is for earthquakes for Utah. Red circles are magnitudes larger than 4. You know, in Utah, we know we can get these events throughout the state. So it's not just in the Wasatch Front along the Wasatch Fault. So throughout the state, we see magnitude 4 and larger earthquakes. And if we zoom in on the Milford area, we actually see that there was a magnitude 4 earthquake near Milford back in 1908. And there was a magnitude 3.9 in 1998. So these are just earthquakes. They're just the result of stressing in the crust from natural tectonic processes. In our analysis of the Milford area, we found some seismic events. We primarily characterized seismic activity in this region as having low seismic rates and small magnitudes. The majority of seismic events on the map shown in the blown up map here are less than magnitude 2. And they sort of divide into 3 areas. There's a polygon labeled quarry. These are largely related to the mining and quarry activities northwest of Milford. The larger events, those 4s, tend to occur near the airport area. They're very infrequent, so seismic activity in this area is even lower than rates in other parts of the Milford Valley. Most of the seismicity tends to occur under the Mineral Mountains. Some of this being natural seismicity related to just, again, natural tectonic forces in the crust. We have a swarm zone where we get little bursts of seismicity occurring in this area. And then there's also seismicity that's associated with the Blundell power plant. But again, these are really small earthquakes and they've been going on for a very long time. They aren't felt because they're so small, but they occur just in the background, okay? And that's a lot of what happens with induced seismic events is they're just really small and they occur in the background. Sometimes they can get larger, and so we looked at what we might expect for a larger event in this area, looking at what the activities associated with Forge and fluid volumes. We're looking at maybe magnitude 2 or 3. To be conservative, we've been looking at models for magnitude 4 to see what the implications of that might be. And whether or not you get to these larger events depends on having pathways to basement faults. So we also went and looked for basement faults, and our imaging techniques aren't perfect, but we don't really see any clear signs of large fault structures that would support a larger earthquake in the area. But as I said, it's somewhat imperfect, but we don't see anything that leads us to that conclusion. So we've been working on this magnitude 4 as our scenario earthquake. And for those of you who were in the area in January, you felt the magnitude 3.9, or many of you did, that occurred under the southern Mineral Mountains, about the same distance from Milford as the Forge site. You know, about 140 people reported feeling this. We didn't have any damage. This is what we'd expect for this size of event, and this is what we expect if for some unusual reason we get a magnitude 4 under the Forge site. So we're even going to go further. We've been working on mitigation strategies. So the first thing you should know is that Seismograph Stations monitors earthquakes in Utah 24/7. There's a duty seismologist and a senior scientist on duty 24 hours a day, 7 days a week. In addition, if something happens, we are backed up by the United States Geological Survey through the Advanced National Seismic System. Typically in rural areas, we set our thresholds for waking people up in the middle of the night at about 3.5 because they aren't commonly felt. Some places are magnitude 3. In urban areas, they're set to 2.5. So sort of under the Salt Lake Valley, Wasatch Front area, or St. George, our alarming thresholds are 2.5. So we're going to put the 2.5 out here at Forge so we know what's going on. So that means that someone's going to get up in the middle of the night if there's a 2.5 or larger event and review that seismic event within about 30 minutes. We'll also produce shake maps, and stuff will propagate to the web in real time automatically. We've also put together a mitigation plan. And again, we've been looking at the magnitude 4. We don't want to get to 4 or larger. So we want to make sure that these earthquakes aren't, anything that's induced at the Forge site isn't really noticed, and we certainly don't want damage. So we're going to do what we can to mitigate the possibility of a magnitude 4 or larger. And so how we're going to do that is we're going to look at the rate of earthquakes that occurs and the size. So in any given 24-hour cycle, if we see 10 magnitude 1 or larger earthquakes in that Forge footprint area, or a magnitude 2 or larger earthquake, we're going to be more cautious. We're going to call a meeting, we're going to slow things down, and we're going to potentially change activities at the well so that we, will change the injection rates or volumes. If there's a magnitude 3 in this larger area, all activity stops. They'll flow things back, and everything will change, and we'll look at what's happening to better assess the situation. Okay. So all of this information you're going to be able to find. It's going to go to the website, quake.utah.edu/Forge map. If you want just Utah earthquakes, don't add the Forge map for Forge. This will be here. You can see earthquakes as circles. You can click on them. You can get more information. The triangles are seismic stations. If you click on those, you can actually get an image of the web recorder. And with that, I will say thank you.